Tonight I'd like to talk to you guys about a conversation that's occurring around the world. And the question we're asking is whether or not we can use ecosystem restoration as a tool to improve people's lives and also as a tool to enhance biodiversity conservation. There's my title slide, sorry about that. So this right here is the cover of the New York Times, I believe in 2013, right after Hurricane Sandy, and it highlights this discussion we're having. And the editors who wrote this article, slow down, feedback, we're proposing that we think of a new future for Manhattan, a future that incorporated restored oyster reefs, restored salt marshes, restored dunes along the coastline here, and that those systems, excuse me, I can't go backwards. I can't go backwards on that, we'll just stay with blue crab. That those systems are going to provide positive impacts for the humans and nature there, including protecting the shoreline from storm-generated waves, provisioning fisheries production, cleaning and filtering the water, so increasing water quality in those environments. And the detractors in this discussion are suggesting this is very difficult to do because of the cost. It's cost prohibitive to restore ecosystems at a large scale. My message to you guys tonight is that if we incorporate positive species interactions, such as cooperation, into the designs of restoration of these ecosystems, we can overcome that expense. And I'll show you in the next couple of slides how and why we can do that. First, these naturally occurring positive species interactions are in our systems, and we found those. The second one is that we could and should incorporate them in restoration, and I'll show you that it increases the efficiency of our restorations and lowers our cost immensely. And third is that because these positive species interactions, we can find them anywhere, they're out there if we can incorporate them into our design. So first, let me explain to you that natural positive species interactions are very common in natural systems. I'm an ecologist, and I use experiments and observations to unravel how species interactions affect the ecosystems that we see. For example, we have found over the past 15 years that predators are key for the persistence of coastal wetlands throughout the world. For example, the blue crab that you see here indirectly facilitates the salt marshes along the Atlantic coast of the United States. They do that by controlling densities of this plant-grazing snail. When blue crabs die off or they're overfished, that positive interaction disappears. Snails increase in numbers, and we see huge grazer outbreaks. They form snail fronts like urchins do in kelp beds, and they destroy these marshes and the services they provide. We've also found that positive species interactions are critically important for these systems to recover. So we look at these systems that have been overridden, and if you look here at these circles, what you can see is that the recovering marsh plants, the ones that are growing better, are growing in the group of marsh plants and not by themselves. And that occurs because the presence of marsh plants, the neighbors that are right around them, activates these positive species interactions. What happens is, as a group, those plants work together to oxygenate the soils, and they benefit from that, so that it increases the growth rates. And this shows us from this example and the experiments we've done at the Duke Nicholas School that positive interactions are really important in natural systems. In fact, if you take those away, it's hard to imagine these coastal wetlands even existing in that environment. So now I'd like to talk to you about positive interactions like this could and should be incorporated into restoration, ecosystem restoration efforts. So what does the restoration paradigm tell us about how we should go about planting organisms if we want to generate ecosystems? Well, in coastal wetlands, our paradigm is based on forestry science. And the basic premise there is you take an organism that you want to generate and you space them out. You avoid competition. It's very Darwinian. Don't let them touch each other whatsoever. And you compare that to the results that we have from our research, it suggests the opposite. That instead, we should be thinking positively about restoration. And maybe we should put these organisms together. So with a group of, which one we wanted to investigate which one of these ideas was right. Should we spread these organisms out, or should we change the design so that they can harness these positive interactions and work together and cooperate as they're building these ecosystems? So I worked with undergraduates, master's students, and PhD students, and we first did a survey across the United States, and we went to all these restoration agencies, and we asked them how they planted their propagules, seagrasses, salt marshes, and oyster reefs, and it turns out they do it just like forestry science. Looks like a little bit like Hair Club for Men design right there, is that these little plugs, and they spread them out so they're not clumping into together, and that's consistent. So the paradigm is consistent in application in those environments. We next did an experiment to test the hypothesis that wasn't the most efficient way. By not letting the plants be next to each other, you were eliminating the potential for positive interactions to emerge in the environment. So we did a very simple experiment. So we controlled the number of outplants that we put out into the environment, working with undergrads, both in the Netherlands and Florida, and simply changed the design. So we either spread them out, which is the paradigm, and then we put together in clump designs. So with and without neighbors in the environment. And if we were right, that clump design should increase production of those plants and the coverage in the environment. And if they are right, it should actually lead to decreased. And we had amazing results, and they were consistent cross-continent, cross-oceanic in the Netherlands and also in Florida. And we saw a 300 to 400% increase in the production and efficiency of the restoration efforts just by planting the plants in a different design. No increase in resources whatsoever. You can see here on Florida's on the left and the Netherlands is on the right. And the top is the dispersed treatments and the clump ones are at the bottom. Look how much more grass you get, and it covers at a much more efficient rate. So these are the kind of results that CEOs just die for, they go crazy for, right? You increase productivity of output with no increase in cost. You just change some of the design in the environment. Let me give you another example of how positive species interactions can increase restoration success. It's right here from your backyard and work we've been doing in Elkhorn Slough, California. Now these marshes are disappearing, they're sinking and they're eroding at their edges. And the idea is that the systems are starved from sediment. There's a lack of sediment in the environment, so we need to spend a lot of money. It's estimated $10 million to bring the sediment back in to save these drowning marshes. They asked me to come out here about 3 years ago and check out these marshes and see what I thought about what was going on. What would we potentially do to save them? So indeed, when I got to the marshes, I saw that they were in trouble. The creek banks were dropping, eroding at the edges. They were sinking in the middle. But I immediately noticed that there was a lot of sediment. There was a lot of mud in the environment. It didn't look like they were sediment starved. Instead of what I saw along the creek bank were super high abundances of crabs. Big crabs about this size, burrowing in, creating like a Swiss cheese architecture and eating the plants. We also walked around these marshes because it looked like some of the other areas were healthier. And indeed, we find healthy area of the marshes, like you see a picture here, and there weren't any crabs. But what we did find, if you could roll the film, it's one of my favorite organisms, and I was completely surprised to see it in the salt marsh. Check this out. Sea otter, right? They're not supposed to be in salt marsh. They're supposed to be in kelp beds, like right over here. Here was a sea otter, and it was eating those crabs. I was ecstatic. I've been working salt marshes all my life. I've never had this big top predator to play with. It's always been small invertebrates. So I was like, is it possible that these sea otters, and they were in high abundance, are actually helping restore these marshes by suppressing densities of those crabs? Is there a positive interaction that's occurring spatially? So you can get correlational evidence, but the way you really do that is you test it with experiments. So you go in there with cages and you exclude that positive interaction from happening. You keep the otters out. And this is what we found after just 2 years, is that this is the control where you have otters, and if you exclude otters, what happens is the population of crabs, it escalates and it triggers die-off of that system. They start eating the roots, they're burrowing away, and the overpopulation of that marsh by the crabs leads to death. And we've done a lot of correlations, and it looks like these sea otters are actually rescuing these marshes in this environment. Now, it's an interesting discussion to have, right? It's $10 million to bring in enough sediment to keep these marshes from sinking. But the sea otters are naturally occurring in this environment. It's about $100,000 for management of their populations in that environment. There's a huge difference in cost there. The sea otters can help restore the system. So this is a discussion we're having. This is a positive interaction that can save taxpayers money and lead to a generation of a lot of ecosystem services. So this shows that positive interactions can really change the outcome of these systems. How prominent are these positive interactions outside coastal wetlands? So we initially did a survey of the literature. I'll just show you some cool pictures. And we went into desert environments and coral reefs and look at the literature. And we found that these positive interactions between plants are super important, and they're all over the place. As these, especially important when ecosystems are trying to come back, okay? When it's a stressful environment, this is the same in economics theory, cooperation can lead to increased success. So it's very common. How about the sea otter result? That's the one that floored us. Sea otters, all your textbooks, they are not supposed to be in salt marshes and seagrasses. Are there other examples of animals coming back and hanging out in ecosystems where they're not supposed to? Are they surprising us? And so, you know, as an ecologist, you just scratch your head and like, well, okay, let's go check it out. So we started to go to marine protected areas in Florida and look to see what was there. And this is what we found in these areas. It was amazing. is that we found alligators in marine ecosystems. They were in salt marshes, they were in mangroves, they were on oyster reefs. This is a big 12-foot alligator we spotted eating a bonnethead shark, and there's one eating a stingray. These animals do not have salt glands like saltwater crocodiles. They are not supposed to live in salt water. In fact, we saw them in even more ecosystems. They've been spotted off patch reefs in Florida. And they're eating marine organisms. So there's potentially. And then we said, wow, I wonder how prominent this is. So we start looking in the literature, and most people chalk these up as sort of aberrant sightings. It turns out large predators like this that could potentially have strong positive impacts on ecosystems are coming back, and they're moving in the new ecosystems. You guys know this well. From the mountain lions are moving out of the mountains, and they're coming into the grasslands in Argentina as well as here. We've done a big survey, and here are some of the examples. There's wolves in British Columbia. They'll swim through kelp beds. They'll pick off fish. Orangutans actually do better in disturbed forests at higher densities than they do in deep, undisturbed forest. Bald eagles are nesting in urban areas. These are bobcats that are incorporating beach areas in the environment. And so we see this, there's like 23 different species that are doing this, and they're moving into these ecosystems. Because they eat so much, they can positively affect plants in those systems. And so just to go back over my points, in conclusion, I'd like to say that I hope I've shown you that positive interactions, they happen naturally. They're in all these different ecosystems, cooperation, mutualism, and they're powerful. They can change the way an ecosystem grows and the way it looks, and it persists. And I've shown you they amplify restoration success. These positive interactions are everywhere. It's not like they're just here on the coast of the United States or in California. They're in China, they're in Australia, they're in these other places. They need to be systematically incorporated. The restoration revolution, most of conservation efforts are about threat abatement. Reduce the threat, the ecosystems will come back. We have to systematically change that perspective and expand the paradigm so that we're also pinpointing important positive species interactions and changing the system. For example, what we're doing with seagrasses is we only plant those where sea otters are. Same with salt marshes, because we know they'll be protected in those environments. And last, what I think is one of the most interesting things here is there's a positive effect on the conservation of iconic species. A lot of these animals can live in a greater diversity of habitats than we ever imagined before. And so when we're thinking about bringing these animals back, there's a lot more space for climate refuge for these animals. Orangutans don't need the deep forest. They can be sustained in a more disturbed forest. So there's a lot of good messages here, but you got to think positively. Thank you very much.